Graphical solutions of inequalities. So we can solve inequalities graphically by shading regions. Now what's going to be involved here are two different variables in our inequalities. So we've previously just looked at inequalities involving x. Now we're going to have them where they're involving x plus y. So we might have something like x plus y is less than 3, or 2x minus y is bigger than or equal to 4. And we can represent the solutions to those inequalities graphically. A couple of rules before we do that. One of them is if the values are included, so we mean if it's more than or equal to or less than or equal to draw the line we use a solid straight line. And if the values are not included, so if it's a less than or a more than, then we draw the line with a dashed line. Once we have that drawn, or once we've drawn the inequality on a graph, we need to decide which side of the inequality is true and which side is false. To do that, we choose a point either side of the line, so 1, 1, 2, 3, whatever, and you substitute it into your inequality. If the result turns out to be true, then we need to shade the other side. So generally speaking, we shade the false side. Whereas if we picked a point on the other side of the line and the inequality turned out to be false, so for instance 7 is less than 3, then we'd know that that point is on the false side, so we would shade it. The other thing that we do that's really good practice is to put in a capital R where the region is. So an R normally represents the region that is true. And we can represent multiple lines on the same graph and then use that overlapping area that's true for all inequalities to solve questions based on that. So if you look at this example then, where we have to identify the region that satisfies these inequalities. So the first one is the line x is bigger than 2. Now x is bigger than 2 is going to look like the line x equals 2. But because it's a more than, it's going to be a dashed line. Now the line x equals 2 is a vertical line which passes the x-axis at 2. So our line is going to look like this. And now what we need to do is decide which side is true and which side is false. So to do that, we pick a point either side of the line. So let's pick 4, 4. So the point 4, 4 has an x coordinate of 4. And if we substitute that into the inequality, we get that 4 is bigger than 2, which of course is true. So that means that all of this side is true and all of this side is false. And we shade in the false side, so everything up to the inequality line. And we can mark that as R, the region that's true. If we look then at example B, what we've got is the line, or the inequality y is less than or equal to minus 3, and that's going to be based around the line y equals minus 3, which is going to be a horizontal line passing through minus 3. The other thing as well, it's less than or equal to, so that means it's going to be a solid line. So if we draw that line, it's going to go along here, so we've drawn a solid line for that. And now we need to decide which side is true and which side is false. So we need to pick a point, and we pick any point. So I'm going to pick 6 minus 6. And what we're doing is we're going to substitute the y value into the inequality. So the inequality was y is less than or equal to minus 3. So we're going to write that as minus 6 is less than or equal to minus 3. And minus 6 is smaller than minus 3, so that's true. So that means the point lies on the true side, which the other side is false. And we're going to score out the false side. And we can label the true side R. Example C is going to be based around the line y equals x. and it's a less than or equal to, so that means it's going to be a solid line. Now the line y equals x shares all the x values and y values, so they're always the same. So it will have coordinates whenever x equals 1, y equals 1, when x equals 10, y equals 10, and when x equals minus 4, y equals minus 4. So when we plot those points, and we can join them up with a straight line, and just like that. Then we need to decide about shading. So we need to pick a point either side of the line. This time I'm going to pick 8 minus 2. And if we substitute those into the inequality, the y is less than or equal to x, we get minus 2 is less than or equal to 8. And that's true, so that means we've picked on the true side, which means everything above the line is false, and we can score that side out and then leave the true side R. The next one then we've got x is bigger than or equal to minus 1. So that's going to be a vertical line passing through the x-axis at minus 1. So it's based on the line x equals minus 1. And it's a greater than or equal to sign, so it's going to be a solid line. So it's a solid line through minus 1. The next one is x plus y is less than 2. And what we've got is the table of values for these. So the way that you could think about this better, it's going to be based on the line y equals 2 minus x. So taking the x to the other side. So then what we need to think about, well, when x is 0, y is going to be 2 take away 0, so that's just 2. When x is 1, y is 2 take away 1, so 1. When x is 2, 2 take away 2 is 0. So we've got our coordinates there. We've also, it's a less than graph, so it's going to be dashed. So our points are 0, 2, 1, 1, and 2, 0. And then we can join those up with a dashed line. Now we need to consider shading. So if we look to shade the x is bigger than or equal to minus 1, we need to pick a point either side of the line. So I'm going to pick minus 8, 2. And I need the x value, so that's minus 8. And that's minus 8 is bigger than or equal to minus 1. Now that is not true, that's false. So that means this is on the false side. So then everything to the right of the line x is bigger than or equal to minus 1 is on the true side. So then we shade in everything to the left of that line. For the line x plus y is less than 2, again we need to pick a point above or below the line. So let's pick the point 8 minus 8, 2 again, and sub it into the equation, and we get minus 8 plus 2 is less than 2. So that's minus 6 is less than 2, and that is true this time. So minus 8, 2 is on the true side, which means everything above it is on the false side. And we shade the false side. So we shade everything above that line. And what we're left with is this region in the bottom, which is true for both inequalities. So this part in here, we're going to label as R. To describe regions, we need to work out the equation of the line that's shown. We need to choose a point in the unshaded region and substitute it into the equation. And then check if the left side of the equation is less than or greater than the right hand side. And then check if the line is dashed or solid and choose from the correct inequality symbol. So in example 20, we have to identify the unshaded region. So what we've got is that the first thing I notice is that it's a dashed line. So that means we're going to have a less than or more than. The other thing is we can see that it's a vertical line. So that's either going to be in the form x equals or y equals. Now if we're not sure, we can just look at some of the coordinates on that line. So the bottom one is 5 minus 5. This one is 5 minus 3. This is 5, 0. And what we see is that every point along this line has an x value of 5. So this has been based around x equal to 5. But because it's a dashed line, it's an inequality, our options are either x is less than 5 or x is more than 5. So now we pick a point on the unshaded side. So we can pick any point, so let's pick 1, 1. And we substitute that into the inequality. So 1, 1 has an x value of 1. So 1 is less than 5, or the option could be 1 is more than 5. Now 1 is less than 5 is true, and 1 is more than 5 is false. But because we want the 1, 1 to lie on the true side, that must mean the equation is x is less than 5. Second example then, what we can see again is it's a solid line, so that means it's going to be more than or equal to or less than or equal to. This is a horizontal line, so if we look at the coordinates, they're all minus 7, 1. We've got minus 3, minus 1, 0, minus 1, and 5, minus 1. So all the y values are minus 1, so the horizontal line is y equals minus 1, but because it's an inequality, we're going to have y is more than or equal to minus 1, or y is less than or equal to minus 1. We need to pick a point, so I'm going to pick 2, minus 3. And if we substitute the y value, which is minus 3, into these inequalities, we get minus 3 is bigger than or equal to minus 1, or minus 3 is less than or equal to minus 1. And we know that minus 3 is smaller than it, so that one's correct, whereas the first one was incorrect. So that means that the equation of the unshaded region is y is less than or equal to minus 1. So the third one here, again, what we can see is that it's a solid line. So that's going to be less than or equal to or more than or equal to. We have a slope line this time, so that means it's going to be x and y. Now we can see the intercept there is minus 2, so that means c is minus 2, and what I'm referring to is, of course, y equals mx plus c. I need to work out the gradient, and the gradient here is the rise over the run. So if we pick 2 points on the line, so one down here at minus 3, minus 5, and another one at 0, minus 2. Then we can work out the gradient being rise over the run to be minus 2 take away minus 5 over 0 take away minus 3, and that gives us 3 over 3, which is 1. So the equation of the line is y equals x minus 2. But because it's based on the inequality, that means we've got y is less than or equal to x minus 2, or y is more than or equal to minus 2. So what we need to do then is pick a point on the unshaded side. So this time I'm going to pick 0, 0 just for convenience. So if we substitute those into the two inequalities, we get 0 is less than or equal to 0 take away 2, which is just minus 2. Or we get 0 is bigger than or equal to 0 minus 2, again minus 2. 0 is not bigger or less than or equal to minus 2, it is in fact bigger than minus 2. So that means the inequality has to be y is bigger than or equal to minus or x minus 2. Next example, we've got 2 lines on the graph. So if we deal with this one first of all, that's a horizontal line passing through the y-axis at minus 1, and it's a dashed line, so it means it's going to be either y is less than 1 or y is more than 1. If we pick a point on the unshaded side, so let's pick the point 3, 2, that has a y value of 2, So we've got 2 is either less than 1 or 2 is more than 1. And obviously 2 is bigger than 1, so that's the true one. So the equation of that dashed line is going to be y is bigger than 1. We then need to look at the slopey line, and it's going to involve x and y, so it's going to be the form y equals mx plus c. It's a solid line, so it's going to be y is less than or equal to mx plus c, or y is more than or equal to mx plus c. So we need to work out the gradient and the intercept. Now the intercept is 1, so it's going to be plus 1, so c equals 1. Then we need to work out the gradient. What we can think about is the gradient is showing that for each horizontal unit we pass, we're going down 2 units. That means that the gradient then is going to be minus 2, because the rise is minus 2, the run is 1, and minus 2 divided by 1 is minus 2. So what that means is the equations are going to be y is less than or equal to minus 2x add 1, or y is more than or equal to minus 2x add 1. We can use the point we picked before, so the 3, 2, and substitute that in. The y value is 2, so we get 2 is less than or equal to minus 2 times x, so minus 2 times 3, which is minus 6, plus 1. Y, which was 2, is going to be bigger than or equal to minus 6 plus 1. So they work out to be 2 is less than or equal to minus 5, which is not true, and 2 is bigger than or equal to minus 5, which is true. So that means the inequality is y is bigger than or equal to minus 2x plus 1. So example 21, on the grid, mark the region R whose coordinates satisfies the inequality. So we've got x is bigger than minus 1. So x is bigger than minus 1 is going to be a vertical dashed line that passes through the x-axis at minus 1. So it's going to be this line here. Y is less than or equal to 3 is a horizontal line passing through the y-axis at 3. It's also a solid line because it's less than or equal to 3. So it's going to look like this. And then y is more than 2x minus 3. That's one where we're going to have to think about the table of values there. So if we have the line y equals 2x minus 3, and we pick our x and y coordinates, let's pick 0, 2 and 4. When x is 0, 2 zeros are 0, 0 take away 3 is minus 3. When x is 2, 2 2s are 4, 4 take away 3 is 1. And when x is 4, 2 4s are 8, 8 take away 3 is 5. So we've got our 3 coordinates there of 0, minus 3, 2, 1, and 5, or 4, 5. And we can join those up using a dashed line because it's a more than inequality. So we get this dashed line here. So now we need to decide about shading. So we need to pick a point, and I'm going to pick a convenient point for all 3. So I'm going to pick 1, 2. And we substitute those values into each of the inequalities. So the first inequality is x is bigger than minus 1, so it's involving the x value. So that's going to be 1 is bigger than minus 1, which is true. So 1, 2 is on the true side of the dashed line, so we're going to shade everything outside of that. We then can substitute 1, 2 into y is less than or equal to 3, and it's the y coordinate we're interested in. So we get 2 is less than or equal to 3, and again that's true, so the point lies on the true side of the blue line, so I'm going to shade everything above the dashed line. And then The third inequality involves both of the coordinates. So y is 2, so 2 is bigger than 2 times x, which is 2 take away 3. So that means 2 is bigger than minus 1, and again that's true. So 1, 2 lies on the true side of the dashed line, which means everything below the dashed line is false, and we're left with this unshaded triangular region here. And we'll label this R. The next example then is find the inequalities which describe the unshaded region R below. And what we've got then is if we first of all think about the dashed line. So the dashed line is going to be of the form y equals 2, and that's because it's a horizontal line passing the y-axis at 2. But because it's a dashed line, it's going to be either y is less than 2 or y is more than 2. To know which it is, we need to pick a point in the unshaded bit. So I'm going to pick the coordinate 2, 1, and we can substitute that in. Now in 2, 1, the y coordinate is 1, so then it's going to be y is bigger than 2 or y is less than 2, and clearly 1 is less than 2, so the equation of that line is y is less than 2. If we then consider the diagonal line going down the way, it's a straight line and it's going down, so that means it's going to be of the form y equals mx plus c. And that's because it's a diagonal line. What we can see is that it crosses the y-axis at 0, so that means that c is 0. And we need to work out the gradient. Now the gradient is the rise over the run. So this moves to the right 1 square and down 1 square, right 1 square and down 1 square, so that means the gradient is minus 1. So that means the equation of the line is y equals minus 1x plus 0, which is just the same as y equals minus 1x, but because it's an inequality, and because it was a solid line, it's y is less than or equal to. So we have the two options of y is less than or equal to minus x, or y is bigger than or equal to minus x. We can substitute in our point 2, 1, and the y value is 1, so we get 1 is less than or equal to minus 2, or 1 is more than or equal to minus 2, and 1 is more than minus 2, so then this equation is going to be y is more than or equal to minus x, and we can write that in. We then need to look at the third line, and that's the one that slopes up the way. And what we can see, again, it's going to be the form y equals mx plus c. The gradient, or the intercept, is minus 2, so we know c equals minus 2. And then we need to work out the gradient. Now the gradient looks that for every 1 square we go across, we'll go 1 up. So that means the gradient is also 1. So the equation is going to be y, and it's going to be either less than or equal to or more than or equal to, because it's a solid line, and that's going to be x take away 2, or y is more than or equal to x take 2. We can sub in a point, so we'll use the 2, 1 again, and we can see that y is 1, so that's going to be 1 is less than or equal to 2 take 2, or 1 is bigger than or equal to 2 minus 2. 2 take away 2 is 0, so this would say 1 is less than or equal to 0, which is not true, whereas 1 is bigger than or equal to 0 is true. So the equation there is y is more than or equal to x take 2. One of the other things that we can do with these inequality graphs is to maximise and minimise them, and that's by using the region that we work out. The maximum or the minimum will always occur at one of the vertices. Now a vertex is just a corner, so it's going to be one of the corners of the region. So we only check those points rather than every single point in it. So let's look at an example on this. So we've got the region bounded by x plus y is less than or equal to minus 7, y is bigger than 2, and y is less than or equal to x plus 1. So if we consider x plus y equal to minus 7, because that's what the inequality is going to be based on. To do that, we will write it as y minus 7 take away x. So we need our table of values, x and y. So let's pick x values of -6, -4 and -2. So y is -7, take away -6, so that's -7 plus 6, which is -1. When it's -4, we get -7, take away -4, so -7 add 4, which is -3. And when it's -2, -7, take away -2, -7 add 2, so that's -5. So we've got coordinates of -6, -1, -4, -3, and -1, -5. So that's going to be a solid line through those points. What we need to do is then look at the next one. So y is bigger than 2. Y is bigger than 2 is a horizontal line which passes through 2. It's a bigger than graph, so it's going to be dashed line. So it's going to look like this. And then the third line is y is less than or equal to x plus 1. And again, we need to think about a table of values for that. And that's going to be based on the line y equals x plus 1. So our x and y coordinates, this time let's pick -2, 0, and 4. So y is -2 plus 1, which is -1. It's 0 plus 1, so 1, or 4 plus 1 as 5. So we've got coordinates of -2, -1, 0, 1, and 4, 5. And we can join those up, and again this is going to be a solid line because it's a less than or equal to graph. Now we need to think about shading, so we pick a point, and I'm going to pick 1, 1. And if we substitute those into the inequality, so the first one, x plus y is bigger than or equal to -7. So we've got 1 plus 1 is bigger than or equal to -7. So 2 is bigger than or equal to -7. And that is true. So 1, 1 lies on the true side, so we have to shade everything beneath that line. Then if we put it into the second inequality, so y is less than or equal to 2, we get 1 is less than or equal to 2, and again that's true. So 1, 1 is on the true side of the red dashed line, so we shade everything on the other side. So we'll shade everything above the dashed line. And then the third inequality, y is bigger than or equal to x plus 1. So that's going to be 1 is bigger than or equal to 1 plus 1. So 1 is bigger than or equal to 2. That's false. So 1, 1 is on the false side of our third line. So we shade everything beneath the line. And what we're left with then is this triangular region. And everything in that area is true for all the values, and we can label that with an R. Now we need to see about minimizing the region and maximizing it. So the first one is x plus 3y, and we want to find the biggest value of it. So what we do is we look at the coordinates and the corners, the vertices. So this is the point 1, 2, and this is the point -4, -3. And if we substitute those in to x plus 3y, at 1, 2, we get 1 plus 3 times 2, which is 7. At -4, -3, we get -4 plus 3 times -3, which is -13. There's a third point that we can't see, and that occurs at -9, 2. So it forms a triangle, and the third point is there. And if we substitute that in, we get -9 plus 3 times 3, which is -9 plus 9, which is 0. So to get the maximum value of x plus 3y, it's 7, and that occurs at the point 1, 2. For 2x minus y, again we look at the values around the edge, and if we look at 1, 2, we're going to have 2 times 1 take away 2, which is 0, and at the point -4, -3, we get 2 times -4 take away -3, So that's minus 8, add 3, which is minus 5. Now there is a third point that we can't see in our graph, and the other corner of this triangle actually has the points minus 9, 2. So we need to try that as well. And if we put that into 2x minus y, we get 2 times minus 9, take away 2, which works out to be minus 20. And in fact, that then is the minimum value. So the minimum value is minus 20.